Hello, am I audible? Okay, so I have created this one basic diagram for the school project. Uh, for now, like we had just in our project, we are having the controller related to the student, basically getting the class details. So in our controller, currently we are having the endpoint related to like admission of the student, and then how many students are there in our class, adding the student to the class, updating the class details. But to explain that in the broader way, considering like teachers, students, class notes, fee payment, then different roles of the person. So I have created this basic architecture, yet it is not complete, but we can try to, I will explain that like what it is as of now. So first is the student. So this student we are having, like we have already created this with the following fields: student name, student roll number, class ID. Same fields I pasted here. Then for the teacher is also will be having the similar details similar to the student, like its personal details basically. And then it will having one teacher ID for the identification purpose in the school. And then its email ID, teacher name, and that teacher will be having the linking with the classes, like how many classes it will be teaching up. So one teacher can teach to the multiple classes. So we need to store the data related to the teacher and the class into a common table that is known as the teacher class table. So in teacher class table we'll be writing like which teacher is teaching the which class. So that relationship will be putting into a new table known as the teacher class table. Similarly, similarly to what if let me go to the home. Yeah, it's not. Yeah, now it is scrolling. So I was saying like teacher with the class, one relationship will get created basically, and that relationship will be stored into new table basically. So this relationship I am putting into the new table, and yeah, I think I can this way. So this relationship will be stored in the new table, teacher class table. And similarly a class will be having details related, like one class should have the class ID, then there will be a limited seat in a class, so we can write as a class size. Then like for particular year it's start date, like class is started date, so enrollment start date I have written, and when that class is ending particular year, so enrollment in date. Then there will be class notes. For that particular class there will be a particular fee amount, and then there will be a class teacher for that class teacher email for the if any contact required, and what subjects we are teaching in the class. So this kind of the fields I have listed here. The names will we can change, but as a broader perspective I have written the these fields, like we can add these fields in our class table. Now, similarly, like we'll be having the like similar to the teacher class, we are also having the relationship for the student and class. So student class details will be putting into the student class table, and the student class table will be having one student class ID as a primary key of that table. Then like one student will be attending the multiple classes, maybe that is the possibility. And in one class, like one student will be attending the multiple class, and one class can have the multiple student. So to maintain both relationship we are having this common student class table. And so it will be having the ID, admission date, admission status, who has enrolled for that student. Enroll in the sense like whenever any student go for the admission, and if they are generally parents go together, so they fill the details and they give their personal IDs, email IDs. Am I audible clearly now? Hello. Okay. Thanks. So same thing, like so in the student class, we'll be having these details related to this admission. Along with that, in that student class, we'll be having the also the students like relationship with the student table and then class table, because this is a student class combined table. So in that we need the student like this student table basically. If I write with the arrow, this student table will further connect with this table will connect with this table, like student class table. So it is more confusing, but there will be a relationship between the class table to the student class. Similarly, this class table relationship will be with the student class. So both fields will be present here in the student class table. These two fields I have written outside student and class, but that is a part of the student class table. Similarly, we'll be conducting the different test. I mean, in schools, in each class, we'll having the different test, like quarterly test or annual test or half yearly test. So those test related dates, like when that test is starting, when that test is ending, and which kind of test it is, like quarterly test or annual or half yearly. And then there will be particular ID for that test. How many times, if the person get failed, so how many times it can attempt, like one or two we can give basically. Then that test will be conducted in a particular class. So the test table also will be having relations with the class, because in a particular class one test can be conducted for each, for different classes. If it is a quarterly test also, then ID will vary basically, and their syllabus will also vary. So here one more field we can add as like syllabus we can add. We'll see later on if okay, let me write here related. So here we can write as syllabus also. And then next table I have created as student test. So this simple test table will be having the test related data, like it is related for the which class and which kind of the test it is. But one student is also appearing for the multiple test. It might be like a class related test. It might be he's attempting some external test, like some kind of the training test, and if he is passing that test or not, and so that kind, and how many marks he obtained. So those details will be listed into the student test table. We can basic architecture behind creating these different tables is we can hold all these data together, but to differentiate and fetch the particular data related to the class, student, or their relationships, we are creating the different table to make the more uniqueness and to avoid the like duplicate data. So in database RDBMS architecture, basically, we are having the concept of uh, we are having the concept to avoid the like duplication of the data. If you, so to avoid those all of the things, we are having the different tables, and this is known as the normalization in database. So if anyone is interested, they can discuss, like they can check on over the internet, like what is the normalization. So normalization helps to uh, reduce redundancy. Redundancy means duplication of data, duplicate data. Then it maintains the atomicity. Atomicity is known as the uniqueness. So in short form, there is a acid property, basically acid. So A for is the atomicity. Then similarly, like I'm not able to recall this other full form, but this is a Okay, I will check on this, but there are four properties related to the acid basically. So those all properties are resolved with the normalization. So anyone can got the question like why we are creating the different tables. That we can put all the details in the single table also. So there are two reasons for creating that. One is to add the different properties to the table, and other is like in a single table a lot of data will be there. So suppose one table breaks down, like one table got deleted or breaks. So in that case, our all data will get deleted. Suppose, for example, test data get deleted. So if the single table data get deleted, so the all tables will not impact much because of that. But if we keep everything in a single table, so if the one table get deleted, it whole our data loss will happen. So to avoid the data loss also, we are having the multiple tables. And so we can say, right, like, to avoid data loss also, we can implement multiple table architectures. So along with this normalization advantage, we are also having the advantage of the like to avoid the data loss in the single table and to make the simplicity like anyone can understand. Because if there are like in single table, suppose 250 columns are there, so it will take a lot of time to the people to understand. But if we divide in those fields into the different tables, anyone can go and they can check the 10 fields, 15 fields around. So this is the like idea behind creating the different tables. Now in past, like we have created the entity. So these tables are created in the in the entity package. So in the entity package, in the format of class, I have just added only the names, like just created the class. So student table was already there, and so I'm keeping as it is for now. Then I created the student class. So similarly, this rest of the class are blanks basically. So as per our diagram, we can add the fields to it. So okay. Now next thing will like I will add the fields, but we need to see like what other things. If suppose we have add, what will be the next step once the field is added? So I was writing that one here on top, I was writing the relationship between the different tables. So there is a concept of foreign key. So what I want here, like there are two tables, student table and class table, and I want the combining the data of student table and class table into a common table, student class. So just for example, I'm explaining this like so in the student table, primary key will be the student ID, or I can say as a roll number of student. Similarly, in the class table, there will be a class ID as a primary key of that table. Primary key in the sense like unique ID. So unique ID in the class table will be the class ID, and in the student table, unique ID will be the roll number or student ID. So to make it simple, I will take it as roll number. Here is student ID itself, and then like with help of the single ID, we can get the data of the whole table basically. For example, if I'll go to the SQL, and in the so currently there is no data in the table. I will take the another. Suppose I am taking the employee. I'm just searching one table where data is there. So here I have opened the employee table, and in that you can see the employee ID is there. So to get the data of this 101 completely, I can write the query in this format also, like where emp id equal to 101. And if I enter with this ID only, I'm able to get this complete row. So the point here I want to make you understand is, like with the single ID, the primary key, we can get the whole row data. So all fields we can get. So if I want to combine the data of the student table and class table into a common table, so there is not required to add all the fields inside this table. We can directly map on the basis of student ID. Student ID I can write here in the student class plus class ID. So if I write the only two fields into the student class table, then also I can get the data of all the columns from these two tables, student table and class table. So to get the all the data from these two tables on the basis of only IDs only, I can fetch complete data. So just to make here, yeah. Okay, so this is known as, like here, whatever the primary key is in the main table, like here the primary key is student ID, and in this table primary key is student class ID. So those primary keys, if it is used in the another table, so in another table it will work as a foreign key. So primary key of the any table which is used in the different table, that will be known as the foreign key for the new table. This is a foreign key for the student class table, and there will be a primary key for the student also, student class also, student class. So here I am writing the primary key. This is ID for student class ID I can write. So this primary key is for this table, like student class table, and this student ID is a foreign key, and it is a primary key of a student table. Similarly, this is coming on here. It should be here only. This class ID. This class ID is a primary key of the class table, but since it is being used in the student class table, so here it will act as a foreign key. So this is the concept of foreign key and primary key. Now we have to basically link the tables. For linking purpose, there is in Java relationships from one table to other. There is a concept of mappings. There are four types of the mapping in Java: one to many, many to one, many to many, and one to many, many to one, many to many, and one to one. So there are four types of mapping. Here the mapping means, like for example, I'm writing here one student, one class can have the many student. So here the class is the single and students are many, so their relationship will be like one to many, many to one. So if we reverse the same thing, like multiple students in the single class, so that will be relationship of the many to one. Many to many, like we can have for example teachers. So in one class there will be multiple teachers, and the teachers are like going to the multiple classes. So both side many to many relationship. So for example, just I'm writing, it might change also. So teacher plus if I say like class, so there one teacher can have the multiple class and multiple teacher can have the one class. So here basically many to many relationship we are establishing. Now in this scenario it might not fit, but I'm just giving the example. So subjects, for example, I will take the subjects and the class. So here subjects will be the many in a single class, like in one class can have the many subjects. So this is known as the many to one. So when the many is written, it means the subjects. One is written means class. So many subjects in one class, that is known as a many to one. Similarly, one to many, like one class can have the multiple, like I will reverse this. So multiple subjects. So same thing is there, but order is changing. So their relationship is also reversing up. So one to many, many to one, many to many, and one to one we can say like class teacher. If I say like one class will be having the class teacher. This is class teacher is not a table, but as a relationship, I'm saying like one class can have the one class teacher, and one class teacher can have the will be the class teacher for the one class. It can be also for the many classes, but in this case, I'm giving the example as one class. So this is a one-to-one relationship, and so just it was for the explaining purpose, but there might be the different scenario where the one class can have the one teacher can be the class teacher for the multiple classes. So that depends. But in general scenario, one teacher will be the like class teacher for the one class, since sharing the responsibility of only one class at a time. Okay. So now this was the related to the relationship. Whatever this relationship I am writing, it is written in the format of annotations. So annotation for this is at the rate one to many. For this annotation will be at the rate many to one. So I will explain in the code. It will be more clear in the code how we are using these annotations. I think I need to check this. I'm not sure it's not used much. One to one. So this four kind of the relationship will be done between our classes, between all these diagrams, whatever we have prepared. There will be a particular set of relationship between these different tables. So it's not scrolling. Yeah. So there we are having almost like 1, 2, 3, 4, 5, 6, 7 to 8 tables we are having. So there will be the different kind of the relationship, either the many to one or one to many. Most probably we are having many to one or one to many relationship only between these different tables. And what else? So this is the basic architecture, like table level relationship we are developing. And here the same flow will be like from controller to service to DAO to entity. So I'm telling these things again because now, like in our code, there will be multiple controllers. If someone want to get the data related to the scores, so he will call the exam controller. If wants to get the data related to the teacher details, then he might call to the teacher controller. So we can create the different endpoints, and we can keep in the single also. But again, the same the here we need to create the different, because we want to create different functionality into the different controllers. So to segregate the functionality, we can create the new controllers as per our requirement. And then for the each entity means each table. For the each table, there will be a particular repository, because there might be some we can use the CRUD repository. I mean, create, update, delete. We can use the existing one, find by ID or delete all or delete by ID. That existing features we can use, but in some scenario we have to create our own query. So for our own query, we need the different set of repository. So for all of the tables, we'll be having the repository also. What- Okay, it's not going down. So hmm. So each entity will be having separate repository, and then for modularity purpose, different modules we can create. Modularity purpose for different modules, we can have the different controllers. So different controllers will be having different service layer will be having for them. But it is not necessary like in one service you'll call only one class or only one entity. There is a relationship between them. So internally they will be calling to the different tables, like with this relationship on the basis of primary key, foreign key concept. It will call the data from the different table into the service. But if the functionality level we want to differentiate, so different controllers, different service layer we can create. And then, yeah, different controllers, different service and repository. Now same thing we need for the exceptions also, like now different kind of the exceptions we need there. General exception will be course, suppose someone want to take the admission in a class and that class has expired. I mean, that class is of old class, currently it is 2023, so that class might be of the 2022. So in that case we can write like class does not exist. Class does not exist, or invalid class we can write. Similarly, if some student is there, and student student is not currently, so some student has already passed, and he is not in the school now. So in that case we can say like student not present. So basically, after a particular time, a student will be also leave the school. So for them, we can say like student not present. And so similarly, different exceptions we need to create. So different exception classes will be also created, basically for the different functionality. Okay, I tried to give the basic description on the basis of the diagrams, and then the different classes relationship. And next step will be to take all these fields, all these respective fields into our respective classes, entity classes. And then once that is done, along with that, we need to write these annotations. Uh, one to many, many to one, these annotations are there. So mostly people stuck there in the case of the annotations, like what annotations they should use. It might be scenario like for some cases many to one will work, some cases one to many, so it will confuse many times. But we need to be sure like what is our requirement. In our case, what should happen. So it might be like that same scenario is applicable for the different cases for different schools. But in current school, what architecture we are preparing, there we need to define like what should happen. Like here, for example, I was saying like many to many I've given, for example, teachers and class. Like one class have the multiple teachers and one teacher can have the multiple classes. But sometimes what happen, like there are the individual classes like tuitions, individual classes. Like suppose tuition classes are there, or training courses are there, training classes. So in those cases, for a particular class, particular training class, there will be only one teacher. So there one-to-one relationship will be there. So I mean to say like for same scenario, teacher and class, there might be the cases where the one-to-one relationship or one-to-many relationship will happen. But we need to make sure like for what purpose we are using. So we are using for the different grades, 1, 2, 3, 4, 5, 6, 7, 8, like up to the 12 we want to use. So there many functionality should work. Okay, so now we need to see just first what we will do. um, we'll write the classes for the one. Let me go to the entity package. So I mean to say is first we'll create the relationship between the student and the class table. So class table I also need to create. So first we need to create the relationship between the student class and student class. These three tables we can create internal relationship, and then we can go for later on about the test, teacher class, and different tables. So one class, first I will write the like what will be the class features fields. It might take time. So now like currently what I will do, I'll write the fields for three classes: student class and student class. So I'm not sure copy feature will work, but here ID will be there, class size will be there. So let me write private. Suppose I'm taking as integer for now. This is a class ID, then private, and int size I'm taking of that class. And what else is class size, create date. So there are different date formats like zone date time if you use. So zone date time is for the purpose of internationalization. Like if this class is in the America, then it will give the America timestamp. In New York timestamp. If it is in India, it will give the Delhi timestamp. So if you want to make on the basis of location, like create time, then we can give the zoned date time. Zoned date time we can write as a create date. Also, if you want the simple date, like a common date, then here just I need to write the date time, and I need to write like, so we need to see what is, there are a lot of things are here. Okay, zone the date time is So simple date also we can use if we don't want the time. So Java util, Java date we can use, or SQL date also we can use. So simple, I will write like update date, or I will reverse this basically. While updating, we'll need the exact time. While creating, we can just write the date. So these fields I'm adding as random, like whatever in diagram I have written. A class ID, class size, create date, enrollment start date, enrollment end date. So it might be scenario like class has been created already, but its start date is different. So in that purpose, like we are writing the enrollment dates. What else is there? Notes, fee amount, class teacher. So this fee amount we can keep also, and we can maintain a finance table also. So for example, for now I'm commenting this.